They're anxiously waiting to see if the New Horizons spacecraft, after a 3 billion mile journey, successfully snapped pictures of Pluto during its close flyby this morning. They should know later tonight, but already the mission is raising the profile of the little dwarf planet in ways previously unimaginable.
Hey there, space enthusiasts. Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is your ticket to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. When considering our solar system, most people can identify the 8 main planets, spanning from the barren Mercury to the icy giant Neptune. Pluto, often cherished as one of the most beloved worlds, and beyond it, the snowman-shaped Eris visited by NASA's New Horizons in 2019 come to mind. However, our solar system extends further. There are numerous Pluto-sized worlds beyond, including dwarf planets like Eris, Makemake, or Haumea. Moreover, within the Kuiper belt and scattered disk beyond, other large, icy celestial bodies have been found, likely dwarf planets awaiting official classification. These are parts of our solar system that many may not have heard about. While the International Astronomical Union, responsible for Pluto's reclassification, currently acknowledges only 5 dwarf planets within our solar system, in reality, the cold reaches beyond Neptune probably host many more of these peculiar worlds. According to the IAU's criteria, a celestial object must orbit the Sun, not be a moon, have sufficient mass for gravity to form it into a nearly round shape, yet fail to clear its orbital path of other objects to qualify as a dwarf planet. This criterion played a significant role in Pluto's reclassification and the establishment of the dwarf planet category. Beyond Neptune lies the Kuiper belt and scattered disk, where icy remnants from the solar system's ancient formation abound. Although not officially classified, this region has already yielded numerous potential dwarf planets, each possessing unique characteristics. Take Gonggong, discovered in 2007 and named after a Chinese water god blamed for tilting Earth's axis and causing floods. Gonggong boasts an estimated diameter of about 1,230 kilometers, making it one of the largest trans-Neptunian objects discovered. Orbiting the Sun once every 554 Earth years, Gonggong spends most of its time in a highly elliptical orbit, billions of kilometers away. At its farthest point, it stretches more than 100 times the distance from the Sun to Earth. Its most notable feature is its red surface, likely attributed to tholins, complex organic molecules formed when simpler compounds like methane react to cosmic rays and ultraviolet light. Tholins impart a reddish or brownish hue to the surfaces of many distant icy bodies in the solar system, such as Eris, the Kuiper belt object visited by New Horizons in 2019, and the distinctively colored regions of Pluto. In 2010, it was revealed that Gonggong has a companion, a dwarf moon named Xiangliu, captured in images from the Hubble Space Telescope. Named after the 9-headed snake monster from Chinese mythology, Xiangliu measures approximately 100 kilometers in diameter. Its orbit around Gonggong suggests it may have formed from an ancient collision, akin to the hypothesis of how our own moon was created. Interestingly, calculations indicate that utilizing a Jupiter gravity assist in the early 2030s with a spacecraft similar to NASA's New Horizons could enable a journey to Gonggong, offering potential for captivating images of one of the solar system's farthest known objects within the next 35 years. Now, consider quaoar, discovered in 2002 and named after the Native American Tonga tribe's creation deity. With a diameter of about 1,090 kilometers, quaoar, like Gonggong, ranks among the larger potential dwarf planets. It orbits the Sun in a nearly circular path, completing one rotation every 289 years, unlike Gonggong's highly elliptical orbit. Quaoar resides relatively closer to the Sun at an average distance of 6.5 billion km, akin to Pluto's orbit. In July 2016, NASA's New Horizons captured a series of 4 images of quaoar from a distance of approximately 2 billion km, offering a unique perspective and the closest ever images of this potential dwarf planet. Even at this range, quaoar appears merely as a moving white dot against a backdrop of bright stars and galaxies, underscoring the challenges in studying these elusive celestial bodies. Quaoar, like many Kuiper belt objects, possesses a relatively large moon named Wewit, named after the son of the Tonpa creator god. A surprising feature of Quaoar discovered by astronomers is its ring system, consisting not just of one ring, but at least two. This finding defied previous expectations, as rings were believed stable only within a specific distance from their host body, known as the Roche limit. Quaoar's rings, extending beyond this limit, challenge established theories about ring formation and stability. Another intriguing characteristic of Quaoar is its slightly oblong or egg-like shape, rather than being predominantly spherical. This shape may result from its rapid rotation, causing it to slightly elongate at the equator. Similar to gonggong, Quaoar could potentially be explored through a flyby mission. Utilizing a Jupiter gravity assist, a spacecraft could reach Quaoar in just 13.6 years, with proposed launch dates as early as December 2026, offering the possibility of close-up images of this enigmatic object sooner than anticipated. Now consider Orcus, discovered in 2004 and named after one of the Roman gods of the underworld, often referred to as the anti-Pluto due to its orbit mirroring Pluto's on the opposite side of the Sun. Orcus takes approximately 245 years to complete one orbit, slightly shorter than Pluto's 248 years. Orcus also hosts a relatively large moon named Vanth, resembling Pluto's moon Charon, with a diameter of 475 kilometers. Despite sharing similarities with Pluto, Orcus is smaller, estimated to be around 910 kilometers in diameter, less than half the size of Pluto, yet not significantly smaller than Quaoar. Nevertheless, Orcus meets the criteria set by the IAU for a dwarf planet. Interestingly, Orcus, one of the lesser-known bodies in our solar system, presents a striking surface coloration that ranges from neutral to a slight reddish hue. This distinctive coloration hints at a composition likely dominated by a blend of water ice and organic compounds. This intriguing mix not only sets Orcus apart, but also suggests a surface that may be relatively young or less weathered compared to similar dwarf planets such as gonggong and quaoar. The youthful appearance of Orcus' surface could potentially be attributed to past cryovolcanic activity. Cryovolcanism involves the eruption of icy materials rather than molten rock, which in Orcus' case could have resulted in cryovolcanoes spewing ice magma across its frozen landscape. Such processes contribute to the dynamic evolution of icy bodies in the outer solar system. Orcus is notable not only for its unusual surface features, but also for its significant size and the presence of a substantial moon named Vanth. These characteristics collectively elevate Orcus to the status of a prominent candidate for dwarf planet classification. Its size places it among the larger members of the trans-Neptunian region, where it resides alongside other celestial bodies that offer clues to the early history and evolution of our solar system. These are only a few of the larger and confirmed dwarf planets in our solar system that you may not have heard of before. However, there are numerous others such as Sedna, Salacia, Varda, or Ixion, which, although requiring further study, likely meet the criteria for dwarf planet classification as per the IAU standards. As astronomers continue to investigate and analyze these mysterious objects, we draw nearer to comprehending the vast and diverse array of intriguing bodies located at the outer reaches of our solar system. Reflect on our collective surprise when we first observed Pluto up close, and consider that each of these unclassified dwarf planets may potentially unveil even more discoveries. And that's it. I hope you found this video enjoyable. If you did, please remember to subscribe and like the video for more content in the future. Thank you for watching, and I look forward to seeing you next time.